Okay, 2.6 part 3. I'm going to start at the bottom of page 89. The first example says, using the sandwich theorem, find the horizontal asymptote of the curve y equals 2 plus the sine of x over x. Well, we're interested in the behavior as x approaches positive and negative infinity. And since 0 is less than or equal to absolute value of sine x over x, and it's less than or equal to 1 over x, we look at it this way. The limit as x approaches positive and negative infinity of 1 over x is equal to 0. So when we replace that with that 0, we find that the limit as x approaches positive and negative infinity of sine x over x is also 0. So when we evaluate our entire function, when we find the limit as x approaches positive and negative infinity of 2 plus sine x over x, we find that that's equal to 2 plus 0, which is 2. So the line y equals 2 is my horizontal asymptote. You look on page 90, I'll show you the graph. And it says this example illustrates a curve that may cross one of its horizontal asymptotes many times. It happens. It's going to cross it a few times. We can investigate the behavior of y equals f of 1 over x as x approaches 0 by investigating f of t as t approaches infinity, where t is equal to 1 over x. Now, example 7 is the step function. It's finding the limit as x approaches 0 from the right of x times 1 over x. Now, I want you to look in your book on page 90 at this graph. The graph of the greatest integer function, y equals the greatest integer of t, is sandwiched between y equals t minus 1 and y equals t. Y equals t is this line, y equals t minus 1 is here, and we see our function is the blue. So what we need to do is we need to find the limit as x approaches 0 from the right of x and 1 over x. So what I'll do is I'll replace my x's with my t's. Remember that t is 1 over x, so 1 over t is x. So this is the limit as t approaches infinity of 1 over t times t. And we see from the sandwich theorem that t minus 1 is less than or equal to t is less than or equal to t, gives me that. Then I multiply through by 1 over t. When I multiply everything, I'm going to get 1 minus 1 over t less than or equal to 1 over t times t less than or equal to 1. It follows from the sandwich theorem that the limit as t approaches infinity of 1 over t times t is equal to 1. So 1 is the value of the limit that we're looking for. Let's look at example 8. Example 8 says the limit as x approaches infinity of x minus x squared plus 16 under the radical. Because both of the terms approach infinity as x approaches infinity, so what happens to the difference is unclear. We don't know what infinity minus infinity is. We don't know which one's bigger. So we are going to multiply the numerator and the denominator by the conjugate of the radical expression. So we're going to multiply the numerator and the denominator. Now, of course, the denominator here is 1. We're going to multiply that by x plus the square root of x squared plus 16. When we do that, the numerator, we're going to do FOIL. We're going to get x squared minus, this is going to be squared, which is going to eliminate the radical, x squared plus 16. It's still one term, so it's still in parentheses. The denominator is going to be x plus the square root of x squared plus 16. And we are finding the limit as x approaches infinity. Well, I'm going to do a little work on the numerator. I'm going to distribute, and that's really going to say x squared minus 16. So this is really the limit as x approaches infinity of negative 16 over x plus the square root of x squared plus 16. As x approaches infinity, the denominator becomes very, very large. So if you get a very, very large number and negative 16 divided by that, you're going to get a limit of 0. Now let's look at the limit laws and see how that works. We're going to divide everything by x. So I'm going to have negative 16 over x, x over x. When I divide by x and I have to put it under the radical, it's going to make it x squared over x squared and x squared there. So this is going to have a limit. So I divided everything by x. When I divided by x here, I had to make it x squared because it was under the radical. As x approaches infinity, this will go to 0. This goes to 1. And this goes to the square root of 1 plus 0. Well, the denominator is going to end up being 2, but 0 over 2 is 0. So this limit is 0. Now we're going to talk about oblique asymptotes.